Okay, so welcome everybody. Thanks for being here. So the way we'll run the class will be slightly different because I usually try to kind of give you problems that are similar to the ones that I'm asking you to solve in the lab, but because I've now lost the ability to stand over your shoulder and kind of jump in to help you while we're meeting together in lab, the way I will do the Thursday streams is I will just sort of do a walkthrough of the labs and solve them and talk about how what it is that I'm doing to solve them. Sorry for the tea, but I'm talking a lot on these teaching days, even more so than before. Just when I'm streaming, I end up talking a lot more. All right, so let's see who's here. A Space Queen, hello. Baby Doll, hello. Bye Bye Boomer, Chaz, Eva, Jordan, Knucklehead, Lemon Juices, Lionel, OHG, Rory, Tony the Cat, Boss Nate, and X Tuffy. Hello, everybody. So today, the one difference today will be that we're making up for the fact that we didn't have class on Tuesday. So normally during the week, what I will do on the Tuesday is I will go over the core concepts being introduced that week, followed by a question and answer session. And then on Thursday, I will do a walkthrough and describe how I am solving that week's lab, followed by question and answer. So today what we're going to do is work through Lab 7 because not everyone completed Lab 7 before spring break. And then take a short break, which is when I usually go get myself a glass of water and rest my voice for a minute or two. And then we will do Lab 8, and then we'll have the question and answer session. One thing I want to show you before we get going too far is that I've changed the way the labs work. So since I'm not there to check off your labs physically in class, I've set up an email account for you to email your work to. So you'll notice every lab now has this new line on it that says email your completed .go file to fubt.grader@gmail.com. That will, for those of you who know Dylan, he's around and helps us during lab. So Dylan has access to this account just like I do. So both of us can process your work, which lets Dylan keep making some money doing his teaching assistant work, and also will help me handle the extra grading load that's going to be happening because of our online teaching style. So anyway, you can feel free to jump in on chat whenever you like to, and stop me if you see me making a mistake, because I've been at this and will be every meeting. Will have been at this for several hours, so I'm probably not as sharp as I might be otherwise. That's a good question. Let's get that. We should answer that right at the start. So the deadline for labs. So I plan to get up on Saturday mornings and process a lot of your work from that week. So we'll say that the deadline for labs is Friday, sometime before you go to bed, so that when I get up first thing on Saturday morning, all that work will be there for me to process. So this week will be a little bit different because we'll catch up on Lab 7 from before spring break, and then we'll also do Lab 8. I'm going to do walkthroughs on both of those labs today. So you'll send both of those in before tomorrow ends. And then next week we will be back on track and we'll do Lab 9. The projects will be the same as they were before, so you'll be left to do more independent work on the projects like before, and then you'll email those by the deadline. So that's how those things will go. What I'm going to start with real quick is just, yes. So the recordings will be here in Twitch. So once the broadcast is ended, you'll find in my videos link here on Twitch, the videos will be there. But I'm also pushing them over to YouTube. If you look down, see if I can get my finger pointing. Well, you can't see that. But anyway, on the Twitch screen, there's a broadcast schedule, and if you scroll down, there's additional information. There's a link to my YouTube channel. So you'll find videos of these broadcasts on the YouTube channel and here on Twitch. The reason why I moved them to YouTube is because Twitch, I think after 60 days or so, they delete videos unless you pay them money, and I'm not paying them money, so they'll be in both places for you to view at your leisure. So technically, you don't have to be here during the live broadcast. It's just an option for you, and you can then use chat to ask questions on the fly if you have them. You can also email questions if you have them, and I'll do my best to answer. Okay, so I'm going to do a little just setup in terms of telling you what's about to happen. So let me make some notes for myself. So today is the 26th. Okay, so this is just sort of a very quick summary of the concepts that these labs have in them. The sort of the underlying techniques. So really the Lab 7 concept is functions that return multiple values. And we're about to work through Lab 7, but that's really all it is functions that return multiple values. Lab 8 concept is really it's a mix of different kinds of functions, which I'll describe as I work through the lab here in a little while. It's also, let's see, I don't like that double dash right there. Lab 8 also has in it the fancy word is orchestrating. So the other thing that you'll see in Lab 8, and I'll come back and review the concepts before we get to Lab 8, but the other thing you'll see in Lab 8 is trying to give you some experience in, okay, now I have a whole bunch of functions in my code. How do I actually pull those together to make them work as a single unit, as one program, by calling a function and then calling another function and calling another function. That's kind of what Lab 8 is about. And sorry if you've come in after I've been greeting people. I'm kind of trying to get through sort of 2 labs in one lab session. So hopefully I won't go too much longer than the hour that I would normally set aside for this. But also I'd ask for your patience so we can get through these 2 labs and get ourselves back on track for the rest of the semester. Okay, so Lab 7 has 2 files in it. It has the test, which you've all seen before. The test you don't ever touch. It just tells you whether or not your program's working. And then, of course, you have lab7.go, which has a bunch of incomplete functions in it. So what I recommend and how I work, normally the first thing that I do when I get a setup like this is I just run the tests and see what happens. So I'm gonna. I need to hide the browser from you for a bit so you can see what I'm doing. All right, so I'm gonna go into my terminal over here, and I'm gonna fire off the test, which you do with Go test, right? Now I'm gonna fail absolutely everything, and that's expected because I haven't touched any of the code yet. And what I'm gonna do then is just do one function test until I'm done. So the area circle, I just did these a few days ago just because I usually go back and work through my own labs pretty regularly. So I know that the area of a circle is pi r squared. Which we might note like that. But that's really pi times the radius, right? Which is the way I'm going to solve it because that makes perfect sense to me. The radius is being provided as an argument or a parameter to the function. So I don't know what the value of the radius is, but that doesn't matter. If I have something representing the radius, then I can compute the area of the circle. Pi in Go is actually accessed using the math library, and then capital P pi. So this is something that's actually in the Go libraries already defined. So I don't have to remember it's 3.1419 whatever. I just type math.pi, and that gives me access to the value of pi from Go. When I save this, something's going to happen in my editor. So to use math.pi, my editor did this automatically. If you're using Atom, that's Go Plus that does that. But anyway, you need import math if you're going to use math stuff. So my editor put that in there for me, but I need to import math to use math.pi. And then I just say times the radius times the radius. That's what I want to return as a result of this function doing work. The radius squared times pi. Radius times pi. That right there is the float 64 that I want to return. So I'll save that. So the other thing, it's a minor part of this lab, but I'm also just sort of having you practice a little bit more sort of common math operations. So in this case, it's geometric things largely, just to practice the math. Okay, so the area of a circle receives a radius and then computes and returns a float 64 that's supposed to be the area of the circle. And the formula to do that is pi times the radius times the radius. So I'm going to finish that one, and then I'm going to go back and test again. If I go test with -v for verbose, I'll see the one that I passed. Hopefully, did I pass any? I did pass one. You can see it. They don't necessarily run in order, but there's the pass that I got on area of a circle, and that's the one that I did. Okay, so that's that one. The area of a rectangle. No, where am I? Yeah, area of a rectangle. So that's pretty easy. That's just a width times a height. So I'll replace the returning a 0 result and instead return the calculation of the width times the height. And then when I go test it again, so that one's probably the easiest one in the whole lab. There I'm passing area of a rectangle, and I'm also passing still area of a circle. I don't know who these people are, so I'm going to block them. So hold on a second. We got to block the Beverly Hillbillies show here a little bit. Okay, so this is just for students at Butte College and enrolled in mine, Boyd Trollinger's CSCI 20 class. So I want to keep the chat to a minimum so that when I look over there, it's questions from my students and not from strangers out in the world. Okay, so there's the circle one and the rectangle one are passing, and we'll just work our way down. By the way, if you forget, you can just look up, like, how do you compute the volume of a cylinder, which I'll do real quick just to make you feel okay about that. It's what I would do if I forgot. So volume of a cylinder is, if you look up here, it's pi times the radius squared times the height is the volume of a cylinder. Pi times the radius squared times the height. Okay, so volume of cylinder is pi times the radius times the radius times the height. So remember that pi is predefined in Go, so we can just use pi. Radius we get as a argument to the function. We don't have to know what the value is, just take the argument to the function, and then we also multiply it by the height. Lab 8 is due this week. So Lab 7 and 8 are both due this week, before the end of Friday, so that we can get them, start grading them on Saturday. Okay, so volume of cylinder, the built-in math.pi times the radius squared, which is really just the radius, times the height, and then I'll go back and test. So I'm passing area of a circle, I'm passing area of a rectangle, and now I'm passing volume of a cylinder. Okay, so volume of a box is really just the length times the width times the height. Which, if you look on Google, that's what it'll tell you. The length times the width times the height. So that one's pretty easy. The length, width, and height come in as parameters to the function. So I just compute it and return the result. So that one's pretty straightforward. Volume of a box. So now I'm passing volume of a box and still passing volume of cylinder, area of a rectangle, and area of a circle. All right, the next two are the harder ones. So let me bring up a browser and just show you what I'm about to do for the distance between 2 points. I better say Pythagorean. So if you notice over here, it says the Pythagorean theorem in the code. So I'll add that to my search. Click on the first link and see if it does what I want. Is there a formula in here? It's in there, but not in an easily consumed way. No, I don't want a video, but let's see if this Khan Academy one. Anyway, what I'm showing you here is that it's perfectly fine. You're not expected to memorize all these things. It's perfectly fine to go look it up. Okay, here it is, right here. So it was on the third link for me. The formula is the square root of, see the b's? So like x2 minus x1 squared plus y2 minus y1 squared. Take the square root of that. So this one has uses a bunch more of the Go math stuff. This is irritating if these aren't students of ours. If I block you and you're in my... Yes, you can turn labs in early. That's perfectly fine. So you'll notice I'm going to stop occasionally and block people who I think are just sort of sitting in on the video and are not necessarily students. I'm getting a lag right now. So anyway, if I accidentally block your chat, please email me and I'll make sure not to do that again. But for now, if it looks like someone who's not one of our students, in other words, they're basically trying to interrupt your class that we're doing because of this virus thing. I'm going to block them. Okay. So anyway, I just showed you the formula I'm going to use, the distance between 2 points, and then I'm going to implement that. So it's an x2 minus x1 squared plus a y2 minus a y1 squared. Take the square root of that. And I'm going to do it in parts. So the first thing I'm going to do, and notice in the code, I actually have an XY pair here, and then another XY pair here. So the first thing I'm going to do is compute the X part, the X difference, which is x2 minus x1. And then you can square that using the math library. So math.pow takes one number, in this case x2 minus x1, and raises it to a power. So I'm going to raise x2 minus x1 to the power of 2, which is another one way of saying x2 minus x1 squared. I'm going to do the same thing for the y part. So I'm going to raise to the, if I can type it. So I'm going to take the y2, subtract the y1, and then square that. That's that y part. And then the last part is to take the square root, and math has a function for that too. I can take the square root, and the square root is that x diff, that's the x2 minus x1 squared, plus the y diff, which is the y2 minus y1 squared. That's the final piece of the calculation. So let's go test it and see if we're getting good on that. There it is, distance between passes. So that one's more complicated. The point there was to sort of show you how to do a slightly more complicated formula. The way I like to do it is to break it into parts, which you'd often do in a math class as well, is kind of break it down into parts. Okay, so the last one, hours, minutes, and seconds. This is really a change-making function, just like you made change with quarters, dimes, nickels, and pennies. This is a change-making function with different currency. Okay, so we have a total number of seconds. They might say, for example, how many hours, minutes, and seconds can you break 9,999 seconds into? Right? Kind of like how many quarters, dimes, nickels, and pennies is 900 cents. So you take a jar of pennies and you break it down. Here you take a jar of seconds and break it down. Remembering that there's 60 seconds to a minute and 60 minutes to an hour. That means there's 3,600 seconds in an hour. So I can immediately compute the hours as the number of seconds I started with divided by 3,600. It's divide because I want to know how many whole hours are in there. Just like we did how many whole quarters, if you remember. How many whole hours are in there. Then I'm going to do what we did with the change making before, which is to use mod to take all the 3,600s out. So the second line, what I end up with at the end is a new value for seconds, which is all the seconds that were left after the hours were removed. So now I'm going to do the minutes. Oh, notice, by the way, hours, I use the colon equals because that's a brand new variable. Seconds, I use just a single equals because I already had that variable coming in as a parameter. Okay, so minutes uses colon equals because that's a brand new variable. So I'll take the seconds, which I just adjusted down, took the hours out. the number of minutes in there is simply the number of seconds that I have left divided by 60. Then I'm going to take all the minutes out. So now this seconds is what's left after the hours and the minutes have been accounted for. At that point, I'm done because you can't reduce the seconds down any further. And then what I'm supposed to return in this case is all three of those pieces. So that return 0, 0, 0 is meant to match up with this int, 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 which will be the hours followed by the minutes, followed by the seconds. And then I'll test it. And it's passing. I can do a sort of final go test without the verbose option, -v. And it should show me I passed all the tests. So that's the lab 7. It's got some math in there. I should actually probably change this to say math functions and math.py plus a function that returns multiple values. And then a little bit of practice just with mostly geometry. Okay, so does anyone have any questions about that lab 7? I went pretty fast, so I don't actually need a break before we move on to something else. Okay, so let me get set up for lab 8. Let me save this first. I want to keep this. Okay, so 2 seconds while I bring up the lab 8 stuff. Let me get a fresh copy. Because at some point I wrote myself that one too. Okay, so lab 8's not a tested one. So you just write it and run it and see if it does what you want it to do. So I'm hitting pause here for just a second to see if anyone has any questions before I go through lab 8. Okay, so lab 8. So lab 8 is mostly about implementing. Now there is a new technique. We have done if-else statements, but this is the first time that you've had to use them a lot, probably. But also a lot of it is just about writing multiple functions and then orchestrating them, putting them together so that they make a program. This one does not have a test, so you just kind of have to implement the pieces and then test the pieces. All right, so one thing we're going to be using in here is random numbers. So let me show you how I remind myself how to do random numbers. by looking it up online, and then we'll use some of that code in our program. So I'm going to go, you can't see that right now, so let me fix it so that you can. Okay, so I'm going to do a Google search here. So what I want to search for is Golang random number. And then I know this because I've done it a few times. Any of these will give you the answer that you want, but I happen to like the Flavio Copez one because it presents it in a way that I think my students understand maybe better. So anyway, generating random numbers, that's what we want. And then, so here's this screen has part of what we want, and then there's another screen that has the rest. So the idea of having random numbers here is that the computer can randomly select what they play in a rock, scissors, paper game. They're not true random numbers. They're generated by an algorithm, which means that if you can figure out what the algorithm is, you might be able to figure out what the numbers are going to be. But they're random enough to be fun. So first thing I'm going to do is I'm going to grab all these imports here. No, I'm not going to bother with that just yet. Am I? Yeah, I am going to grab those. So I'm going to grab these imports first, and I'm going to put those into my program. Now I'm going to go back and I'm going to grab this bit right here and see where it is right inside of main, and that's where we want to put it in hours. I'm highlighting it, by the way, and using Control-C to copy. And then just like they did, I'm going to put it just inside main. And in fact, I'm going to move that comment up because that's what that is. Yes, perfect. Thank you, baby doll. That's perfect. Okay, so if you haven't done random numbers in programming before, I'm going to offer a highly simplified, sort of stripped down explanation of what this is. So the way I picture it is that random numbers are kind of spit out in a series or a sequence. And the algorithm that produces them always produces the same sequence of numbers. And that's bad in theory because if you start in the same place in the sequence, then you always get the same numbers come out in the same order. What seeding does is kind of starts you at a different point in the sequence every time so that it looks like the numbers that you're getting are quite different. But a simpler way even to say that is if you don't seed for random numbers, you won't get numbers that appear to be random. You'll get the same sequence every time. So that's the first step from, that's two steps, the imports and the seed value from the Flavio Copez site. And then I'm going to scroll down and I want to grab this bit right here. This ran.int n max minus min. So I'm going to copy that, Control C. Now that piece I actually want in my computer play function. Now I'm not quite there yet, but that's where I'm going to use that piece because that's where I need a random number to happen. All right, so this thing right here, ran.int, it returns a random number between 0 and a specified number. So for example, If I put a 10 here, I'm going to get a random number between 0 and 9. And less 1. Less 1. If I put a 10 here, I'm going to get a random number between 0 and 9. So if I want a random number between 0 and 2, I'm going to put a 3 in there. So from 0 to this number less 1. So I will get a number 0, 1, or 2 if I do that. But that's basically the whole algorithm for the computer's play. So I'm just going to take that. And make that be what, that's the whole function basically. Is give me a random number that's 0, 1, or 2. Which is what this will do. From 0 up to 1 less than the number you specify. That's the whole computer play. Nice, yeah. Is that how you did it too? Yeah, it is how you did it. All right, and then we're going to go down to main. So after we do a function, let's go down to main and try it out. So if you look in main, there's this place here that says call that function. So you want to pay attention here to this function when you call it because it returns an integer. Yes, yours works perfectly. Yeah. So yours is perfect, baby doll. It's perfect. Okay, so when we call it, we need to be aware of the fact that it's going to return an integer. So when we call it, since it returns an integer, I want to capture the integer. I'll call that the computer pick. So the computer pick will contain the random number that this function returns. By the way, you guys, if you look at the chat, Baby Doll has a really good idea, which is she has it commented out, but it can be helpful while you're setting up to see what happens. So I might do something like this. Make a note for myself that this is for testing, and then the computer pick is so I can see what it was. You don't want to print this when you're playing the actual game because that ruins the game, since they would always know what the computer picked. But we can now go run the program and see if the computer's picking 0, 1, or 2. So let me hide the browser so you can see my terminal again. Nope. So the computer picked 2. I'm going to run it a few more times. Pick 2 a couple. There's a 1. There's a 0. Back to a 2. So you can do this for a while, but you sort of get the idea that for testing purposes, I can see that my function is, in fact, giving me a computer pick that's 0, 1, or 2. I'm going to leave that there for a second. Okay, so now let's work on computer play. Player play. So this is a prompt for read in and return an integer value. So this means not random, but the player typing something. So let's make ourselves a variable for this. Then we'll prompt You can make your prompt whatever you want to be, but it's helpful if you tell them what they're supposed to do. So I just have a little thing here telling the human, type 0 if you want a rock, 1 if you want scissors, 2 if you want paper. Then I'll do a scan to get what they type in. And then I'll return what they typed in. So that's this int right here is what the function is supposed to return. So that's all that function does, is it tells the player what they're supposed to do, it gets what they type in, and then it returns it. So it can be used elsewhere in the program. Just like the computer play, all it does is pick randomly for the computer. The player play function, all it does is let the player play what they want. All right, so now let's go back down to main and same thing. So call player play. But we remember that player play returns an integer. So we need to capture that. And I'm going to do another testing output. Just to see if the number that they type in came back right. Both of those outputs are going to go away eventually. Then we'll go run it and see if those things work. So there's the computer getting a random pick. I'm going to pick rock 2 just to see. So you pick 0. I'm going to try it with all of my possible picks just to make sure it works. Okay, so the function works. It's getting my input and it's sending it back for the program to use elsewhere. Is everyone doing all right, hopefully? Let me get a sip of tea. Now remember, normally I'll break this down and go a little bit slower, but I'm trying to get 2 labs worth in one broadcast. So this one's fairly short, although we're coming up on the harder stuff. Okay, so let's implement the print play function. Remember, when you're implementing functions, especially the way I give them to you, you don't know anything beyond what you have to work with in the function. So I have a player name here. I don't know what the player's name is, but I have a variable representing it, and I have an integer representing what they played. So now I have to write code to make that all work. So the first thing I'll do is just print out their name. So played. So I'll start just by the name. Now notice I did not put a new line here, and I did that on purpose because I need to also then figure out if they played rock, scissors, or paper coming up here. But I can certainly do that part first. All right, so now the harder part, which is based on what they played, yeah, it's nice. That was a good idea, by the way. Now, if you look at Baby Doll's chat, she handled the situation where someone played an illegal play. Okay, so print play for some player and what they played. And I'm going to kind of follow Baby Doll's model. So that play right there, this is where the if statements come in. So if the play was 0, that's rock. So I will print out rock. There's the new line character. So what's going to happen is it's going to say somebody played space rock new line when the play is 0. Else, if the play is 1, So this is another possible outcome, right? Then scissors. Or it could have been 2. So else if it was 2, it was paper with the new line. This else right here is anything else. And anything else, something is wrong. So I'm going to put a statement like something not allowed. So say like Jane played something not allowed, or this shouldn't happen very often, but just in case, we'll have that extra bit of outcome there, so that if the play was not 0, 1, or 2, something at least shows up. All right, now we're going to go try it. This function does not return anything, but it does require that I specify a name and what they played. So now I'm going to go down to main. Let's try it out. So print play requires a name. I don't have a variable for the computer's name, so I will just say computer is a name. But I do have a variable for what they picked. Yeah, those are nice. And then for the player, I'm going to use the same function, but I think I'll call him the human. Different name, and it's not that what the computer picked, but what the player picked. So it'll say like computer played rock, and then human played scissors, that kind of thing. So let's try that out and see if it, in fact, does that. I think at this point, by the way, we can probably disable the testing outputs, because print play should show us what's happening. There is a switch in Go, by the way. We're not using it for this lab. We're introducing that in a later lab. So this one is designed to save switches until later. All right, so I'm going to go back to my terminal and test this out. So you don't see what the computer picked anymore, but we know that the computer has already picked, and I'm going to pick paper. So it turns out that the computer played rock, and I played paper. That's correct. So that's where we're at in the program so far. For those of you in the chat who aren't in this class, I don't mind if you watch, but if you're putting comments in chat and you're not a student enrolled in this class, you're distracting it from people who are actually paying me to do this work. And I mean, they're paying the state of California for me to deliver this content. This is a course at Butte College in Oroville, California. And like many colleges, we're shut down and having to work only online. So try to be respectful of that if you would, please. Okay. So let me see who we've got. All right, fair number. Okay, so that gets us all the way up to the scariest one, because there's so many possibilities. But notice I'm just following along in main and kind of doing it what it tells me. Calling the functions. When they return values, I capture them in a variable. I'm using the print play function for both the computer and the player. It works for both because it will print out the name I specify and the correct rock, scissors, paper based on what that either computer or human picked. So the last one is the big nasty one because there's so many different combinations. So there's a bunch of ways to do this. And I'm just going to do it in one of the ways that you can do this. So in this case, the show result function, it takes an integer representing what the computer played and an integer representing what the player played and displays a result. So the easiest one to handle is when they play the same thing. Right? That's a draw. And then just to show you that there's nothing wrong with sort of doing all of the brute force work, I'm just going to go through all the combinations. So if they're not the same, then if the computer played 0 and the human played 1. Now I know that they're never going to be the same anymore because if they were both 0, I already caught that here. So I at least eliminated that possibility from all of them. But it is possible the computer played 0 and the human played 1. That's a rock and scissors. Right? Rock, scissors, paper. Yeah. So in that case, the computer wins. You don't. So that's a good question. So when I'm working inside the function, all I have to worry about is what does the function call those variables. So in the scope of the function, it calls it computer play and human play. Now when I set up to call this function later, I'm going to have to plug in the right variables. But it's perfectly fine if the function calls the variables one thing and another part of the program calls them something else. But that's good to note that kind of thing because that is going to be important when I get back down to main. Okay, so if the computer played rock and the human played scissors, the computer wins. If the computer played rock and the human played paper, then the human wins. That's all the combinations for the computer played rock. So this first if gets rock and scissors, rock and paper. So now we'll go to the computer's playing scissors. We already caught if the computer and the human both played scissors, so we don't have to worry about that one. So if the computer played scissors and the human played rock, the human wins. That's an else if, by the way. If the computer played rock and played scissors, and the human played rock, scissors, rock, then the human wins again, right? That can't be. Someone catch me on this. Rock, paper, the human wins. Scissors, rock. This is scissors, paper, so the computer wins. Nice one. I think you've got some flavor text, baby doll, don't you? Yeah. I'm going to steal from hers in a second so you can see what she did to kind of make this cool. Okay, so that's the other. So remember, I already captured 0 equals 0 and 1 equals 1 up here. So there's the computer on 1 and the human on 0, the computer on 1 and the human on 2. So the last one I'll get is, or 2, the computer playing paper. And the human played rock, so the computer wins. And then the computer played paper and the human played scissors, then the human's going to win. So that's all the combinations. I'm going to try it out, and then I want to sort of show you what Baby Doll did, which is a super cool touch. So mine's pretty dry if you look at it. Oh wait, I forgot to call it. So now if I scroll down to main here, I have to call show result. So the tricky bit that Tanner was asking about was that the first value is supposed to be what the computer played, and in the function it calls it computer play. But in main, I called it computer pick. So as long as I put what the computer's value first, the function will work correctly. The function calls it computer play, but in main I called it computer pick. That's perfectly fine. And then the second value needs to be what the human did, which in main, I didn't even call it human pick, I called it player pick. Which as long as that comes second, the function will work correctly because that's what the human did. So I called the variable something different in the two places, but pardon me, it's as long as they're plugged into the right spot, the function will work. I'm going to try it a couple times here just to make sure that I'm getting a result. So we got a draw on rock. We're going to draw on scissors. Okay, so there I played paper and they played rock, so I won that one. And I'll go the other direction. Draw. I played scissors. I lost. Okay, so let me show you what Baby Doll did, which is really cool. Draw I'll leave alone. But she put some flavor text in here. So for this one as an example, this is the computer played rock and I played scissors. So she put, for example, I might even just steal your words if that's okay. Rock crushes scissors. Computer wins. Just to make it more specific to that specific outcome, which is super cool. So you could do that on all of those and kind of put some extra flavor text in there, which is nice. Since it's random, you may have to play it several times to see all your flavor text, but that's a super cool idea. I'm actually just about dead on where I was, so I had to go faster to get through 2 labs in one day. Scrolling back to the top, so we did want to do some if-else statements. So what would normally have happened is on Tuesday we would have talked about if-else statements separately and then done the lab today. But I wanted you to not get behind on the things that we want to get graded, and also I thought just doing the lab would give you a working example of an if-else statement, and that would help. Oh, you might, by the way, in show result, this will be my last thing. You might have an else down here in the case that something unexpected happens, right? So I'm even going to say that. Something unexpected happened. No result. Just so you're programming, the off chance that the computer or the player pick an illegal value, then they will see something unexpected happen. In fact, I'll just show you that it works. I'll pick an illegal value like 4. So there it said, I played something not allowed, and then something unexpected happened, so there's no result. Which is a way to, it's an extra tool that you have in your toolkit for this. All right, if I If I silenced you in chat and you're part of the class, apologies for that. Please let me know by email. But I do want to keep these the chat limited to people who are actually in the class, so that they get all of their needs met while we're doing this weird online only for the rest of the semester. So thanks for your patience if I accidentally caught you up in cutting you off from chat and you're in the class. Just email me with your Twitch name and I'll be on the lookout for that. I don't want to have to do sort of private class time just because that, but I do want the chat to be focused. It's better practice to force yourself to get in the habit to use variables inside your functions. It's kind of difficult to explain when we're at this stage of the semester. But it's considered good programming practice to not have global variables where you can avoid it. So try to get yourself in the habit of using variables in your functions and return values and parameters and arguments to share data between functions. Okay, so hopefully everyone got it. So I'll put a note here at the top. So I'm switching back over to our notes page. Lab 7 and Lab 8 due this week by the end of Friday, March 27th. And please note the email address on the course page. And at least in that, I can use filters if people are trolling us out of Twitch. And I don't mean to accuse anybody of that. I just... I hope to keep the traffic down to people who are enrolled in the class so I can focus on their needs specifically. Because this is likely to be challenging. It's not what we expected, obviously, and it's what we're going to have to do our best to get through the semester. Okay, so I'm going to sit here quietly for a minute or two and field questions. I will see you on Tuesday next week at 2 o'clock. And then on Wednesday mornings, I'll be here just for question and answer. So I'll kind of just sit here quietly and work on stuff and wait for you to come ask questions in chat. This video will get posted up to YouTube. We can, yeah. So if someone wants to see the computer play function again. We can. So on the lab tag question, let's give it a couple of seconds. And then I'll address that question. Okay, perfect. Then you'll get an answer to yours as well. I'll pull up Lab 10 after I've let all of the Lab 7 and 8 questions settle here. Oh, I'm glad you brought that up. Yes. So I meant to ask you, but so now someone's already weighed in. My other two classes are going to have me set up a Discord so they can communicate with each other. The only reason I'm setting it up is because it's a little easier for me to get everyone invited. So yeah, we'll do a Discord for this class as well, and I'll let everyone know when I've got that set up. It'll probably be tomorrow morning when I get to that. But please monitor your college email, because I will be the easiest way for me to email bomb all of you is through the college's server. So you don't have to send me emails from that account, but please do monitor it so that I can communicate with you. And when I get the Discord set up, I'll send a message out through your college emails for that. Okay, so I'm going to pull up Lab 10. It's still okay if you want to ask me questions about other stuff. But let me go grab lab 10. All right, let me clear this out and remind myself what it was supposed to look like. So you both are working on parallel arrays in lab 10, right? So let me go get a fresh copy. It's large. Okay, it looks like it's probably going to be all right. Okay, so the parallel arrays thing. I'm going to cheat and just use my values that are in here. But probably you both have, let's see, declare an array. So I'm going to do part 1 up here. So products. So products is a string array of 5 elements that includes bread, milk. So for everybody else, this is lab 10. This is a couple weeks down the road, so we will be back here revisiting this from scratch. So you can stick around and watch it, but don't get worried about it. Just have a couple people who are working ahead, and I want to help them keep doing that. So there's my products array of 5 strings: bread, milk, eggs, butter, sugar. Then I'll do a prices array, which is 5 float 64. And I'm just going to steal my values from below. So I had a $1.98, 3.22, 0.68, 2.68, 1.43, $1.43. So the idea here is, probably you knew that, but the idea of a parallel array is that the element in a position in one array is associated with the element in the same position in the other array. So bread is the first element in products, and $1.98 is the price of bread, the first element in prices. Milk is the second element. 3.22 is its price, the second element, and so on. So I think probably you already got that. And there's other ways to do this, but I wanted to show you that sometimes we actually sort of do use a combination of arrays sort of in parallel. Okay, so yeah, perfect. So now the printing of it using a counting loop. So the trick here is you can really only write a loop for one of the arrays, but you're going to use the loop to work with both. So I'm going to do a counting loop, which means I'm going to use an I counter, an iterator. Start at 0 because that's where you start with the arrays. So here I just have to pick one of the arrays to work through, and I'm going to use products. As long as the two arrays that are meant to be parallel are the same size, this will work out just fine. So I'm going to write a counting loop over the length of products. And then I'm going to use the I to access the information. So what I want is to print out the string that's the name of the product, followed by a colon, followed by a $sign, followed by money, so %.2f, and a new line character. So the trick is the string part. It's going to come from products, and it's going to be the item at I, which will be 0 to start, and then 1, and then 2, and then 3, and then 4. That'll get all of these product names. And then for the price part, I need to go into the prices array. But since the products and the prices are in parallel, the product at I is paired with the prices at I. So when I is 0, I get product 0 and price 0, which would be bread and $1.98. When I is 1, I will get product 1, which is milk, and price 1, which is $3.22. So that's how they work in parallel. I'll show you one other trick. Actually, let me just show you 2 versions of this loop so you can try them both out and see if you can figure out what the difference is. Let's say 1, 2, 3, 4, 5, 6. Let's say 8. So this second loop has one tiny little thing different, but I want you to try it out just because it's kind of cool. And see what the difference is in the 2 printouts. So this is what I mean by using the arrays in parallel. So when I access the products at a given position, I'm going to also access the prices at that same position, and I will get related pieces of information. So hopefully that answers that. Sure. Hopefully that worked for both of you. Yeah. So Baby Doll had pretty close to exactly the same thing that I did to process it in parallel. Oh, and all that other stuff in those comments is just to show you that I went and I tried to make realistic prices, so I went and looked them up online. Perfect, great. And if you get a chance, try both versions of this loop. The one with the little tweak in here, just so you can see that little trick. Anybody else? I'll give it a couple more minutes. Yes. So, and Nate, I'll get your question in a second. Lab 7 and 8 are due Friday night this week, yeah. And that'll put us back perfectly on schedule. So when we come back next week, we'll be heading into Lab 9, yes. Nate, the thing I see, and I'll just sort of make a side, it looks to me like you have this inside of it. You have a line that looks like this. Oh, actually. Oh, I see. Okay. No. Okay, I do see it now. No, you have... with some stuff going on in there, but basically... Okay, so the trick here, and She'll probably put her code up. So the trick here is you're trying to use greetings twice in your loop. So the range is for ranging over a collection. So you have a collection that looks like this, something like this. How many do we have? 3 or something like that? So you're trying to range over this collection of greetings. But on the left side is where you have the problem. So on the left side, what you're getting is the position of each individual greeting. So this range thing gives you one at a time. And what it gives you is one location, which in this case would be 0, 1, and 2, and one greeting from that location. So you get the location and the one greeting when you range over the collection of multiple greetings. Which means that your print line here should not be trying to print all of them at once, but just the one greeting that came with that pair of location and greeting. So when we get there, the way I teach this is the thing on the left is in the singular and the thing on the right is in the plural. Yeah, and you see how Baby Doll did it. She called this num. So as long as you're sort of clear that what you're getting on the left is one individual thing as you range over a collection of multiple things. And then what you want to print is the one thing that you got each time. So you'll get a location or an index and then one greeting. So when I is 0, the greeting will be hello. And these values are kind of automatically produced by the loop. So that's what I saw. And Baby Dolls are correct too. Oh, you want your, oh, no. Okay, Baby Doll has a printf to show the entire array. Good point. Yeah, so she did one of these, which is not a bad idea, to show them all at once. And then a loop to print them individually. Which one is that? Oh, yeah. You can probably see how I did it on my screen. Lab 10's not tested, is it? No. Yeah, I still have some teaching assistant help. So if you send a lab that you're unsure about to foobt.grader, the email address on the lab, he'll probably answer you and try to help you. Yeah. So I'm going to wind it down here in a few minutes. I'll wait for questions, but then I'll wind it down. I will be creating a Discord group for everybody in the class.